So measurement of internal resistance of a cell by potentiometer, class 12 physics. So here we have a battery, this is key, that is switch, and between C and D we have potentiometer and it has a jockey J. The potentiometer is represented by a resistance because between C and D you have a piece of wire, but that piece of wire can be represented as a resistance. Okay. Now from jockey we have high resistance in series with galvanometer. You all know that galvanometer will be in the order, it is basically an ammeter which gives a full scale deflection in microamps. So to protect the galvanometer from overloading, you are using a high resistance. Then here we have the cell, we have to find the internal resistance of this cell, and this is connected, the positive is connected to C, and from C you are connecting an external resistance R, it may be say 10 ohms like that. From R you have a key K2, so this will be the circuit setup. Initially what you do is close this switch, that is key K1 is pressed and K2 is open. So if this is open, this is a open circuit. So what you do is, since you have a high resistance, now you try to balance this jockey so that the galvanometer deflection is 0. Actually it will be oscillating. If you try to move this jockey in between, it will be getting oscillating between negative and positive values. At one point it will be 0. You stop at that point and find out the length, which is L1. Actually you will be having between C and D there will be a meter scale. So definitely you know the length. So the voltage of the unknown cell E is directly proportional to L1. Next what you do is, you connect, the switch K1 is closed and K2 is also closed. Now there will be some disturbance in the galvanometer. Now once again what you do is, you adjust this potentiometer so that the current through the galvanometer is 0. If the current through the galvanometer is 0 means, that means what? Between this point and this point there is no current at all. That means this circuit and this circuit is totally isolated. So this can be removed as if. We can imagine that this galvanometer and high resistance can be removed. Okay. So now the resultant circuit here will be the cell, the external resistance R and the key 2. So the key 2 is already plus. The internal resistance of the cell is denoted here, which is small r. The current flowing in the circuit is I. So I is equal to V by R, that is E by R plus R, that's what is given here. Now we have to find the voltage across the resistance R, that is V is I into R is given here. What is I? I from this equation is E by R plus R into R. So this gives you ER by R plus R. Now this is equation 262 and this is equation 263 because ER by R plus R is balanced at a length L2. This L2 is also measured in the potentiometer because you have a meter scale attached to the potentiometer. Now you have two equations. Now L1 divided by L2, that is E divided by ER by R plus R. So this will give you E into R plus R by ER. E gets cancelled and you will be having R plus R by R. That is L1 by L2 is equal to R plus R by R. Therefore, after mathematical simplification, you will be getting small r is equal to L1 minus L2 by L2 into R. Now, if you look into the right hand side, all are known values. What are the known values? We know L1, we know L2, once again we know L2 and the known resistance of R. So, therefore, we can always find the value of unknown resistance of the internal resistance of the cell, which is E. Hope you have understood this topic on measurement of internal resistance of a cell by potentiometer. Thanks for watching this video. Nandri.